Down type, it utilizes the buck converter technique of circuit or switching circuit in order to achieve a lower output compared to your higher input voltage. So for example, you have 12 volts and you need a 5 volts output, so you configure that one into the buck converter circuit in order to do that. So how this buck converter circuit work? So it worked through a fast acting switch, charging and discharging your inductor, and at the same time your inductor charges the capacitor, and in turn you will achieve a lesser voltage compared to your input voltage. So this thing, it is a chip that you can purchase in the market today. That has a good regulation in order for you to have a steady output. Okay, how this thing works? So in the closed state, while your switch here, or fast acting switch, is in the closed state, it should go close fast enough, preventing this inductor to be this way, and you will have this polarity plus and minus here, and charging inductor, and preventing it from being in saturation state. So the switch will open fast enough also. So in the open state, your inductor is in discharging state also. If it is open, your inductor will be in discharging state. So while it is in discharging state, your inductor will have a reverse polarity like this, because that is the characteristic of this inductor, to reverse its polarity while it is in discharging. So look at this. While it is charging, your plus is here and your minus is here, and charging this inductor, going to your capacitor. And when the switch is open, your inductor is in discharging state. You have a polarity plus here and minus here. And what is the purpose of this diode? Is that your negative will have an access to the ground. You will have an access to the ground here like this. And at the same time, you are going to discharge to your capacitor. So this process will be repeated on and on, fast enough for this switching device to charge and discharge your inductor and charging your capacitor. And then you will have your output voltage, that is steady output voltage, that is governed also by the switching action of this chip. So we are going to use this very popular chip, the MC34063. This is an 8-pin chip that has this picture. You have the switch here. Pin 1 is your switch collector. Pin 2, switch emitter, timing capacitor, the ground, and then you have the comparator inverting input. You have the BC plus supply 7. You have the current sensing, and the 8 is the driver collector. So this is the circuit. So this is your comparator that will be used in your voltage regulation. This is your timing capacitor that will give the frequency of switching. And you have here, you have your switch here. Your switch will be connected here. So, and this is it. So operation from 3 volts to 40 volts input, low standby current, current emitting, output switch can carry up to 1.5 ampere. So this switch can carry up to 1.5 ampere. Output voltage adjustable. And it has a frequency of 100 kilohertz, and you have a precision of 2%. So this is now the circuit. So it is like this now. This is the step down. So this is the schematic drawing, and this is our circuit now. See, this is the chip in the middle. So this is the chip now, and our schematic is here below also. So I'm not using breadboard. I'm also using this one because I am comfortable working with this rather than the breadboard. So here it is, how it is connected. We have the pins 1, 2, 3, 4, and then here 4, 5, 6, 7, 8. So it is the same as this circuit here. So here at pin 1, it is jumpered to pin 8, the same as this one also. It is jumpered to pin 8. So we have, I have the capacitor, the timing capacitor, the Schottky diode, a fast acting diode, my resistor. This is 0.33 ohms. So we just followed what is in the drawing here. And now let us power on this one, and let's see. Okay, now our circuit is already set up. We have the scope and the volt meter here. So now the output is 0. This is the output of the circuit. So we don't have output now, and our activity of our inductor also is nothing. So we'll try to increase, and then you will notice, we'll try to increase the voltage, and then you will notice that the activity of the inductor also will increase. So I will give a command to increase the one. I'm using the potentiometer as our reference feedback. So any changes in the potentiometer now will give an corresponding output, that one, either to higher or to lower. So I'll try to increase it. So I'll increase it. See, it's increasing now. Wait. Let that increase. So I will try to increase the voltage. Now is 5. I will increase it and see the activity of the inductor. So the inductor also is charging and discharging while we are increasing the voltage. So if I'm going to increase it more, it cannot reach up to the supply level. So it's always below the supply level. Our supply voltage is about 12 volts, so it cannot reach up to beyond that because we are on the step down mode. Now if I'm going to reduce this one, reduce the voltage. Look at the activity of the inductor also, the switching activity. So it's reduced. So it's keeping up some pulses in order because it's maintaining the voltage of about 8.76 If I'm going to reduce more, so the activity of the inductor will become very less. See, I'm going to increase now. Okay, so we are scoping. Now we are applying load on that. We have a 390 ohm resistor at 10 watts. So let us see what is the response of this one. Okay, we are now at 1 volt. So it will increase the load now. Increase. So it is increasing. So look at the activity of the inductor also. So it becoming busy the inductor to cope up with the load and the regulation of the chip. So see, we have now 5, and then I'm going to increase it. So it can only increase until this voltage 9.8 volts because we already have now the load. So it is steady. I'll reduce now the voltage. Okay, so it's stay at 6 volts. I'm going to reduce it more, and I'm going to increase. See, look at the activity of the inductor. If we try to maintain the output voltage at, let's say, 7 volts, this one. So look at the activity of the inductor. So it's pulsing after some time just to maintain the output of 7.36 volts. Okay, that's all. Thank you. I hope you like it.